Hello and welcome back. In this video, we discuss about three-dimensional force vectors as well as the concept of direction cosines. In the previous video, we discussed how two force vectors can be added to find a resultant force vector. Just by adding the I components and j components, we get the resultant force vector. Now, we consider a two-dimensional vector f inclined at an angle alpha with the x-axis and beta with the y-axis. We can express f vector as sum of its horizontal component fx in I direction and fy in j direction. Since fx is f cos alpha, and fy is f cos beta, where f is magnitude of vector f, we can write vector f as f cos alpha I plus f cos beta j as equation A. In this equation, cos alpha and cos beta are called direction cosines of the vector f. If you see in this picture, this is the magnitude of the vector f, just a straight line without arrows. And that magnitude, when you resolve, you get fx as f cos alpha, and if you resolve to y-axis, you get f cos beta. And cos alpha and cos beta are called direction cosine. Now, the magnitude of vector f can be expressed as square root of sum of squares of its component force fx and fy. Substituting expressions for direction cosines into this equation, we can derive a simple mathematical expression that cos square alpha plus cos square beta equals 1. Vector can also be represented as a unit vector u multiplied by its magnitude as equation B. Equation A and B suggest that the unit vector u along the force vector is cos alpha I plus cos beta j. Now we extend this idea to a three-dimensional vector. So that consider a force acting on a hook, which is acting at angles alpha, beta, and gamma respectively from x, y, and z axis as demonstrated. The projection of vector f on each of these axes is its scalar components fx, fy, and fz along I and j and k direction respectively. This vector can be written in terms of a scalar component as vector f equals fxi plus fyj plus fck as equation A. Now the magnitude of the vector f is square root of fx square plus fy square plus fc square. This vector can also be expressed in terms of a unit vector u and its magnitude. As discussed previously, we can show that the unit vector along the direction of force vector f is u vector equals cos alpha I plus cos beta j plus cos gamma k, where cos alpha, cos beta, and cos gamma are called direction cosines of vector f, where alpha and beta and gamma are angles the force vector that makes with x, y, and z axis respectively. Now, we can derive simple identity as we discussed earlier. Cos square alpha plus cos square beta plus cos square gamma will be equal to 1. Now, consider a simple problem. A hook is pulled with a force of 200 Newton acting inclined 45 degrees to z-axis and 60 degree to y-axis. Express this force vector in terms of Cartesian basis vectors. Note that this force vector is a three-dimensional vector which is inclined at an angle alpha with the x-axis. We can use the identity that cos square alpha plus cos square beta plus cos square gamma equals 1 for a given beta and gamma. We can solve for alpha. Once you have alpha, beta, and gamma, we can write the unit vector along the force as u. The magnitude of the force is given as 200 Newton. Multiplying the unit vector with the magnitude of force, which is 200, we get the force vector in I, j, and k directions as 110I, 100j, and 141.4 k Newton. Another problem, in this case, two forces are given. Find the magnitude and direction cosines of the resultant force vector. To find the resultant, just add the two vectors. Then find its magnitude and then find the unit vector by dividing the force with its magnitude. Since the unit vector is same as cos alpha I plus cos beta j plus cos gamma k, we can find the angles by equating the coefficients of I, j, and k respectively of equation 1 and 2. Here cos alpha is 0.26, therefore alpha is cos inverse of 0.26, which is 74.8 degree. In similar fashion, we can find the angle beta and gamma respectively as 102 degrees and 19.6 degrees respectively. The problem, a three-dimensional force of 60 Newton is acting 60 degree from y-axis and 45 degree from the x-axis and inclined at an angle gamma from the axis. Express this vector in terms of I, j, and k basis vectors. And another problem, for a given vector ni plus phi j, answer the questions A to G. Just follow the steps. Essentially, you're finding the direction cosine of the vector. A repetition problem. A three-dimensional force vector is given, and you have to answer all questions from A to F, which is the direction cosines of this three-dimensional vector. And finally, we have two force vectors given. Find the resultant and the magnitude of the resultant vector and the direction angles of the resultant force, alpha, beta, and gamma. Thank you.